Good morning, children. Today I will tell you some tricks how to answer the questions, and these are important questions. Children used to ask this. First question is, what is a atomic radius? I have told you the distance from center of nucleus to the outermost cell of electron, like this. Center of nucleus to the cell of this cell, outermost cell of electron. This is atomic radius. Second question, what is its unit? Generally asked in examination, what is its unit? Angstrom. 1 angstrom equal to 10 to the raised power minus 10 meter. Or picometer, 1 picometer equal to 10 to the raised power minus 12 meter. Third question, what is covalent radius? This is also atomic radius used for covalent molecule. This term is used for covalent molecule, as I have told you. 1/2 of the internuclear distance between the similar atoms held together by single covalent bond. I have told you these things in some examples already. I have given for hydrogen and chlorine, and there I have explained this is the covalent radius. This is covalent radius. And Cl2H2, these examples I have told you. Hydrogen, it was 37 picometer, chlorine 99 picometer, fluorine 64 picometer by some experiment, and it was also found by 72 by some other experiment, like that. Next is, what is van der Waals radius? Van der Waals radius, that you should have some idea about it. It will help you when you will explain, you will compare the atomic size, atomic radius of group 17 element, other group element with noble gases. Let us see what is van der Waals radius. Van der Waals radius is 1/2 of the internuclear distance between similar and adjacent atoms of the closest neighboring molecule of the same substance in solid state. I am going to tell you an example. Once again, but listen. I told you 1/2 of the internuclear distance between similar adjacent atoms of the closest neighboring molecule of the same substance in solid state. Very important, these terms, remember. One example, suppose this is iodine. Iodine, combine one atom with other iodine atom to form this. And here, this is nucleus, another I2, another I2. Now in this iodine, this distance is here. This distance here, this distance, and again I am showing just the line passing through the center of nucleus, like this. This is the atom, iodine atom in solid iodine, and this is van der Waals radius. But this is what? This is van der Waals radius. And from here to here, van der Waals radius. Van der Waals radius. And this is covalent radius. From which part? here covalent radius, here covalent radius. Van der Waal radius means this is van der Waal radius. Experimentally it was found that the internuclear distance between the non-bonded iodine atoms in solid iodine is 430 picometer. Then half of the 430 picometer is van der Waal radius, half of the 215 picometer is the van der Waal radius. Experimentally it was found 430 picometer, half of that is 215 picometer, this one or this one, and this 215 picometer is the van der Waal radius of iodine. Like that, I want to compare covalent radius and van der Waal radius. Van der Waal radius is always larger than covalent radius. Some examples, like here fluorine, chlorine, bromine, iodine. Their atomic radius are, I have told you, are covalent radius in picometer. I have told you fluorine 64, sometimes 72, here 99, bromine I have told you 114, iodine 133 picometer. But their van der Waal radius in picometer, it comes 135 picometer, 180.6, 181 or 180 picometer, and that one 114, it comes around 195 picometer, it comes just now you calculated 215 picometer. Their van der Waal radius is larger than covalent radius. Remember this. In case of noble gases, we can define noble gases are monoatomic. Then you can define one half of the internuclear distance between non-bonded atoms when they are in closest approach, closest contact. That is called van der Waal radius in case of inert gases, noble gases. Now next question. Give reason why cation is smaller than its corresponding neutral atom. Cation is smaller than its corresponding neutral atom. Answer, how to write. In cation, number of electron is less than that in its neutral atom. Now you can think why? Because cation is formed by loss of electron. However, the nuclear charge in atom and in its cation is the same. So, the nuclear pull per electron increases because electron is less. Then more nuclear charge is here and electron is less. Then nucleus attract less number of electron with stronger force, means effective nuclear charge is increased, which results the shrinking of electron cloud and size decreases. One way you can explain this way. Second way, in certain cases, after the removal of electron, the valence shell or outermost shell is lost, disappears. Outermost shell completely disappears. It results the decrease in atomic radius or atomic size. One example, in sodium atom, there are 11 protons, nuclear charge is plus 11. When it loses one electron, it will form Na plus. Nuclear charge is plus 11, same. but number of electron in Na plus is 10 and in Na 11. Therefore, nuclear pull in case of Na plus per electron means effective nuclear charge increases. As a result, size of Na plus decreases. In this example, by first point you can explain. Second point, in sodium atom, the electronic configuration I have told you 2, 8, 1. If it loses electron, then one outermost cell completely disappears and its electronic configuration is 2, 8. Since one cell, outermost cell completely disappears, therefore its size is smaller. Then two ways are there. You can explain why is cation is smaller than its corresponding neutral atom. Next question. Why is anion larger than its corresponding neutral atom? Same way you can explain. Anion is formed by gain of one or more electron. So, in anion, number of electron is more than that in its neutral atom. However, the magnitude of nuclear charge remain unchanged. As a result, the nuclear pull per electron means attractive force exerted by the nucleus on the electron decreases, which results the expansion in the electron cloud and size will increase. That way you can explain. Let us see one example. When chlorine atom gains one electron, there is formation of chloride ion. In chlorine atom, the number of proton is 17. Nuclear charge is 17. Here also nuclear charge is 17. When it gains electron, it forms anion. Charge is 17. But its electronic configuration, you see, charge remains same. But here number of electron in chlorine atom, is 17. And here number of electron in chloride ion is 17 plus one more gained, 18. Here number of electrons 17 in chlorine atom, but in chloride ion 18. Nuclear charge same. Again, nuclear pull on the outer electron means attractive force exerted by the nucleus per electron, effective nuclear charge decreases. As a result, size of chloride ion increases. That is the way you can explain and you can remember also, and you can answer any question like this. Again, next day I shall tell you another topic. Thank you.